Tom from Technocamps here. In this video we're going to have a look at how to create a traffic light using Tinkercad and Arduino. So that was the challenge that I set you at the end of the previous video, and then we're going to move on to having a look at how to use a sensor with an Arduino so that we can change the brightness of an LED based on how bright the environment is. Okay, so first of all we need to have a think about what does a traffic light do. So there are different ways of thinking about this or visualizing it. On the right hand side I've got a picture that shows what a traffic light does. So we start off with the traffic light being red, and then it moves to red and yellow, then it moves to green, then it moves to yellow, and then it goes back to just red. And I've also added some times in between because the traffic light pauses at each one of these states for a certain amount of time. So it's showing the red light for 30 seconds, and then it moves on to the red and yellow light for 2 seconds, and then the green light for 30 seconds, and then the yellow light for 2 seconds, and then back to the red light. So that's one way of looking at how a traffic light behaves. We could also write it out as a series of steps. Maybe that's easier to think about. So on the left I've got a series of steps that match this picture on the right. So we start with the red light on, we wait 30 seconds, we turn on the yellow light, we wait 2 seconds, turn off the red and yellow lights, turn on the green light, wait 30 seconds, turn off the green light, turn on the yellow light, wait 2 seconds, then turn off the yellow light and go back to the beginning, turning on the red light. Okay, so that's two ways to look at the behavior of a traffic light. We could also create a flow chart. So this is something that you've probably looked at in computer science lessons. And this just shows that same process, but in a sort of more formal way. So we have our start box at the top, all of these angled boxes here. These are input or output boxes. All of these rectangles here are process boxes. So you can see that we output the red light being on, then we wait 30 seconds, output the yellow light being on, wait 2 seconds, etc, etc. We move down following the arrows from state to state, and when we get to the last one we go all the way back to the beginning. So when you're trying to solve a problem, it's a really good idea to think about how you would solve that problem before you start doing any programming or you start making anything. Because if you're not sure how to solve the problem, then the computer isn't going to help you figure that out. So you do really need to figure out what you're going to do before you start doing it. Okay, let's now have a go at making our traffic light in Tinkercad. So I have Tinkercad all loaded up already, and I've already added an Arduino and a breadboard, and I've connected power and ground to these rails on the left hand side. So we should be ready to start adding things. The first thing that I think we should add is some LEDs, because we're going to need a red LED, we're going to need a yellow LED and a green LED. So let me just change the colors of these, and then we can start adding them to our breadboard. So I'm going to put this one, I'm going to rotate them all as well. I'm going to put this one over here, and then this one underneath it. Now we may need to move these around as we start to add other components, but for the moment, rotated that one too far. For the moment we'll put them here. Each LED is also going to need a resistor, so let's find a resistor, and we're going to use 220 ohms as our resistance again. you can actually change this resistance. You could make it smaller, which would make the LED brighter. If you make it too small, then you would damage the LED. If we make this value bigger, then it will resist the flow of electricity more, and the LED will be dimmer. So if you make this value too high, you won't even see the LED turn on. Okay, so how are we going to arrange this? We need to connect one side of this resistor to the LED and the other side to ground. So let's try doing it like this to try and make it nice and compact. Okay. Get another resistor and another one. Set them both to 220 ohms. Okay. And then rotate them 90 degrees. Let's try and fit it all into this small space. Okay, so each one of these is now connected to ground. So you can see this black wire goes from 0 volts or ground on the Arduino, connects to this whole column here. If we follow that up, each one of these resistors is connected to ground and then to one leg of an LED. So now we just need to connect the LEDs to our Arduino. So let's start by connecting the green one. So I'm going to connect a wire from pin 2 to the other leg of my green LED. And remember that these pins on the right hand side of the Arduino, these are all input and output pins, so we can choose whether we want them to be inputs or outputs. We'll be using them as outputs so that we can control the LEDs. Okay, so each one of these LEDs is now connected to a pin on the Arduino. We now need to write some code. I'm going to click on the code button up here and delete the existing code that's always created for us. So what do we want to do? First of all, we want to turn on the red light. How do we do that? Well, the red LED is connected via this wire to pin 4. So if we set pin 4 high, then electricity will flow down this wire into this side of the LED, through the resistor, and into the ground. Okay? When that electricity flows through the LED, it will light up. So let's set pin 4 to high. That should turn on the red LED. So next we need to wait for some amount of time. Now in our flowchart we waited for 30 seconds. That's a little bit too long, I think, for us, because we don't want to wait for 30 seconds just to make sure our code is working. So we're going to wait 2 seconds. So the red light should be on for 2 seconds. And then we're going to set the yellow light on. So remember, the traffic light goes from red to red and yellow. So let's use set pin. And the yellow light is connected to, if we follow this wire, it's connected to pin 3. So let's set pin 3 to be high as well. We're then going to wait slightly less time, so we'll wait for 1 second. Then the next state would be turning on the green light. So let's turn on the, oops, that's the wrong one. Let's set pin 2 to be high. So pin 2 is connected to this wire, which is connected to our green LED. We can't just set pin 2 to high because currently all of the other LEDs are still on. So let's also set pin 4 to be low. When we do that, there should be no voltage on that pin, and therefore that LED should be off. Yeah, so we set pins 4 and 3 to low and set pin 2 to high. So this line should be high, with the green light should be on. These other two should be low, and these two lights should be off. Let's wait another 2 seconds whilst the light is green. And then, well, I think I've forgotten what the next step is. So this is why it's really good to have a flowchart of some sort. So let's go and have a look at my flowchart. Okay, well, it says turn the green light on, wait 30 seconds, then need to turn the green light off, turn the yellow light on, and wait 2 seconds. Okay, so now I know what I'm doing. Let's go back to Tinkercad. I use my output to set pin 2, which is the green light. I'm going to set that low to turn it off. I'm then going to set pin 3, which is our yellow light, to be on. And then finally, we're going to wait one more time, just for a second, and then we will need to turn our yellow light back off. So pin 3, let's set that to low. Okay, so we've converted our flowchart into a set of blocks that should represent a traffic light. So let's try it. Let's press start simulation and see what happens. So we have the red light on, then the red and the yellow, then just the green, then just the yellow, and back to red. Okay, and it keeps on going around and around and around, just like a simple traffic light. Okay, we're now going to move on to having a look at how to read a sensor, in this case an LDR, using an Arduino. Before we can do that, we do need to talk about two different kinds of signals. So we can measure or sense two different types of signal with our Arduino. We can sense digital signals and we can sense analog signals. So what are they? A digital signal moves between a set number of fixed values. This is normally 2 different values. So down here I have a graph that shows voltage on this y-axis and time on the x-axis. So as we go further along, we are going further along in time. This red line shows a digital signal. So you can see that it only has 2 different levels. It either has this one down here or this one up here, and it moves instantly between 2 of them. Okay, so this is a square wave because it is well, shaped very similarly to a square. So you can see that it starts off at one position and instantly changes to the other value, drops down instantly to the lower value, and it keeps on going between these two. So this is a digital signal. An analog signal can be any value between some minimum and maximum. So again, down here I've got a little graph with voltage on the y-axis up here and time along the bottom. And this time I have an analog signal in green. And you can see that it moves up the y-axis smoothly. It can be any voltage as it goes along, as it changes over time. You can see it wiggling around and going through pretty much every point on the y-axis. So an analog signal can be any value between a minimum and a maximum, whereas a digital signal is a signal that moves between a fixed set of values, normally 2. So how do we go about reading an LDR, or a light-dependent resistor? Well, a light-dependent resistor is a resistor that changes its resistance based on the amount of light it's exposed to. So it changes how much it resists electricity based on how much light it is exposed to. It also outputs an analog signal. So if we want to read one of these sensors using an Arduino, we need to use one of the Arduino's analog pins. So that's pin A0, A1, A2, A3, A4, or A5. If we connect it to one of the digital pins, these are pins that can only measure digital signals. They cannot measure analog signals. So if we do that, we will only ever get two values when we read that. We would get either a high or a low. We don't want that. We want a number, essentially, of how bright is it according to our LDR. Now we can't just connect our LDR straight to our Arduino. We're going to have to create a specific little circuit to measure the light, to measure the resistance of our LDR. And this circuit is called a voltage divider. Now, we're not going to go into it because it's not really computer science, it's more in the realm of electronics. But a voltage divider is when we combine two kinds of resistors, and it enables us to measure when one of the resistances changes. Okay, so we're going to have a fixed resistor, a resistor whose resistance does not change, and we're going to combine that with an LDR, which is a resistor whose value does change based on the light. And if we do this in the right way, we should be able to measure the light level. Okay, let's go to Tinkercad and have a look. So I've set up my Arduino and my breadboard again. So it's just the same setup as last time with 5 volts and ground connected to these two columns on the left-hand side of my breadboard. First up, I want to add my LDR. So I'm going to search for it, LDR. Or maybe it's a light. There it is, a photoresistor. So LDR can have lots of different names. In Tinkercad, it seems to be called a photoresistor. Okay, photo being light, so a light resistor. Okay, so let's add one of these. I'm going to plop it down there, rotate it 90 degrees, and just connect it here on my breadboard. I'm also going to need a resistor, so let me just search for a resistor and put that down there. Now this time I need to change the resistance to be 10 kilo ohms. Okay, kilo being 1,000, so 10,000 ohms. So it should be a brown stripe, a black stripe, an orange stripe, and then a gold stripe. Okay, so I'm going to combine this with my photoresistor with my LDR to create a voltage divider. So one leg of my resistor is not connected to anything yet, but the other leg is connected to one leg of my LDR, and the other leg of my LDR is currently not connected. So I need to connect one of these to ground and the other one to positive. So I'm going to connect this leg of my resistor to ground with a wire, just by clicking here and here. I'm going to change the color to be black because remember we use black wires for ground signals. And I'm going to connect the other side, so the free leg of my LDR I'm going to connect to 5 volts, to the positive side, and I'm going to set that to be red. Okay, so that is our voltage divider. We put 5 volts in one side, we put 0 volts in the other side, and this will divide that voltage based on these resistances. So when this resistance changes, the voltage in the middle should also change. So the middle is here, and I'm going to connect a wire to one of the analog pins of my Arduino. Okay. So 5 volts goes in here, 0 volts is here, and we measure the voltage in the middle of our voltage divider. Okay, so that's all set up. We're now going to write a little bit of code. So let me go in here, remove this default code. Okay, this time we're going to use a variable to store our light value that we've read from the sensor. So I'm going to click on the variables tab, this purple one here, click create variable, and I'm going to call my variable light value. Press enter. So I'm going to set my light value to not to 0 as it shows here, but I need to go to the input tab and click on read analog pin, and I'm going to drag that to where the 0 is. Okay, and I'm just going to change A0 to A5 because A5 is the pin that our sensor is connected to. So change that to A5. Okay, so that should read the value of that pin, which reads the sensor, and it should set light value to be equal to that. Okay, so we are storing the value of the sensor in a variable. Now, if I run this, it will run, but we won't be able to see anything. So I'm going to click on the Output tab, and I'm going to find the Print to Serial Monitor block, which is down here. I'm going to add it there. And instead of printing Hello World, I'm going to print my light value variable. So each time this code is run, it should read the analog pin, which reads the sensor value. It's going to store it in the light value variable, and then it's going to print that out to the screen so we can see it. Okay, so I'm just going to, no, I need that. I'm going to click on the serial monitor, and this will let us see any of these messages that have been printed. And I'm going to just move this over a little bit and press Start Simulation. Okay, and you can see it's printing out 54, which is the value of our sensor. Okay, so now I'm going to change the brightness of my LDR. So if you click on the LDR when you're running the simulation, there's a slider, and we can go from dark, which is this black dot at the top, to bright at the bottom. As I do that, you should see the value of the number change. Okay, so I'm just going to press Stop Simulation now. So that's all very well. We've read a value, but what are we going to do with it? I think we should change the brightness of a light. So let's go and find a LED. I'm going to add that to my circuit. So I'm just going to pop that down here. I might just change the color to, I don't know, blue maybe. And I'm going to need a resistor for my LED. I'm going to change it to 220 ohms like we've been using for our other circuits. Rotate it round and connect one leg to ground and one leg to our LED. Then I'm going to go from pin 2. I'm going to go over here and I'm going to connect that to the other leg of my LED, and I'm just going to make that yellow so we can see it a bit better. Okay, so it's not connected to this green wire. These are two separate wires. The yellow one just goes over the top of it. Okay, so we have our sensor connected to pin A5, and we have our LED connected to pin 2. So let's go and write some more code. Let's now set, where's it gone? Let's change the output, so let's turn the light on and off based on the light. Okay, so we don't need this print anymore, okay, because we don't want to be printing it, we just want to be changing the LED. So we're going to need an if statement. So I'm going to find an if statement block and drag it in here. In fact, let's use an if else block. So what we want to know is if our light value is greater than some value, turn the LED on, otherwise turn it off. So we're going to use one of these comparison blocks here. Okay. So this sort of triangle-like symbol means less than. Okay, so if this side is less than this side, the code in here will run, otherwise the code in the else will run. So let's write the code. We're going to set pin 2 to be high if our light variable is less than, let's just say 400 for the moment. So the numbers that we should get back from our light sensor should be between 0 and 1024. So let's put it somewhere in the middle, roughly. Okay. So if our light value is less than that, the value that we read from our sensor is less than 400, turn on the LED. Otherwise, turn off the LED. So set pin 2 to low. Okay. So let's try running that. So now, when it's dark, the LED is on, and you'll notice that as it starts getting lighter, it turns off. Okay. So we've kind of made a night light here. When it's really dark, the LED turns off. When it's light, the LED turns. Sorry, when it's really dark, the LED is on. When it's light, the LED turns off. Okay, so that's pretty neat. Can we do any better? I think we can. I think we can control the brightness of our LED this time. So I'm going to change this wire. I'm going to connect it to pin 3 instead of pin 2. Okay. Now pin 3 is a pin that lets us output an analog signal. Okay, so we should be able to provide a signal to this LED that is not just on or off, it's somewhere in between. So we should be able to change how bright it is. So I'm going to go back to the code, and I'm now going to remove my if block. Instead, I'm going to use this set pin block. Okay, so I'm going to set pin 3 to be light value. So I should get a value that's read in from my sensor, and I'm going to write it back out to pin 3. So the higher the value I read, the higher the value I write back out. Now I can't remember if I've got this the right way round, but there's an easy way to find out. Let's try running the code. Okay, so when it's dark, the LED is dim, and when it's bright, the LED is bright. Okay, so I think that's not quite the right way round. We might have to do some modifying here, if I can find it. Now I think the problem is that we can only output a number up to 255 from pin 3. If we output anything bigger, nothing really happens. So let's use this set variable block to update the number in light value, and we're going to use this map block. Okay, so this should let us change the value here to make it fit between the range that we give here. Okay, so let's just try that with a variable. So I'm going to say take the light value and I want you to give me a number back between 0 and 255. Okay, so it should scale this so that it always fits in this range. Okay, let's try that. Okay, yeah, it works a bit better this time. So when it's dark, it's darker. When it's bright, it's brighter. But I think our night light should probably be the other way around. So it should be on when it's dark. So I'm going to change these numbers to be the other way around. And hopefully that's all it takes. Okay, let's try running it again. Yeah, so now when it's dark, it's bright, or the LED is bright, and as it gets brighter, or the light gets brighter, the LED gets dimmer. Okay, so now we've got the ability to change the brightness of our LED. Okay, that's it for this video. So we looked at how to create a traffic light using the Arduino, and also how to play with an LDR, how to read it, how to take that value and do something useful with it by changing the brightness of an LED.